Hey, I wanted to show you a few things that we could do with the AI implementation of ChatGPT. So what you're looking at here is my interface for ChatGPT. I have signed up for the paid version of ChatGPT, ChatGPT Plus. It's $20 a month. In my opinion, it's very well worth it. The first part I'm going to show you here is what we can do with the free version. And then we'll switch over into the Plus version, and I can show you a few more things that we could do. My overall goal here is to do some data analysis on the transactional data that I've been using in the NNI 637 course, Intro to Database Management. And so it's a data set that shows it's a faux data set that just provides a series of medical record numbers and encounter numbers and shows patient information, diagnostics, and things like that. So you may have seen this data set before. This is an anonymized data set. If we go up to the top here, you can see there's fields: unique medical record, encounter record, discharge, APR, DRG, description and code, ROM and SOI, which is risk of mortality and severity of illness, race, age, gender, financial class name, and so forth. So what I'm going to do is take this data set and feed it into ChatGPT and let it do some analysis. So I'm going to start off, I'm going to copy, say, the first 20 records, because ChatGPT doesn't do too well with large data sets. I'll show you how we can get around that in just a minute. But what I'm going to do is copy the first 20 records of that data set, including the header. I'm going to say, analyze this data set and give me some insights. And then I'll put in some space and put in the comma-separated value representation of the first 20 records. Actually, the first 19 records, and then the first line here is just the comma-separated field names. And then I'll just feed it in, and let's see what it comes up with. So what it does first is it gives you a description of the data set. Like it starts out with unique medical record. This column contains unique identifiers for each medical record. It helps distinguish individual patients in the data set. Now, keep in mind, I didn't feed it any other information other than just the data set, and I ask it to analyze. It's determining what a unique medical record number is and how it attributes information to the overall data set. Encounter record column represents the encounter record associated with each medical record. It might indicate different visits or interactions between patients and the healthcare system. So now we're starting to build up context around this data set. Discharge month, APR, DRG, and you see it knows what APR, DRG is without me even saying anything about it. ROM, it knows risk of mortality. I've gotten some of those questions from my students asking me what is ROM, what is SOI. AI knows what they are, and they're correct. Risk of mortality, severity of illness. Race, age, gender, financial class name, indicates financial class associated with the patient's insurance or payment method. So it didn't have any information about that, it just knew. And then primary diagnosis, length of stay, and then the nursing unit, where the patient was admitted or treated during their stay. So you get a full definition of what this data set looks like. So now it says you can gain insights into prevalent diagnosis, patient demographics, and so forth. So let's ask it another question. Are there any interesting, I can type, interesting insights provided in the data? And so what it does is it goes through, and it's a very limited data set. So we would get better results if we had the larger data set. Some interesting insights can be derived. Prevalent diagnosis. The data set includes various diagnoses such as heart failure, pneumonia, and so forth. This indicates the diversity of medical conditions represented in the data set. Patient demographics, severity of illness and risk of mortality, which we'll see has a correlation in a little while. Columns provide insights into the severity of patient's illness and their associated mortality risks. Analyzing these variables can help identify distribution and severity levels and assess the risk profiles for the of patients in the data set. We go into insurance analysis, length of stay in nursing units, and then this says to gain more insights, it will be beneficial to conduct further analysis and explore relationships between variables such as examining the distribution of diagnosis across different age groups or analyzing the relationship between severity of illness and length of stay. So, well, that's fine. We could say, based on this data set, are there any correlations between length of stay, and risk of mortality. So now I'm just asking it regular questions, trying to identify some elements of correlation between different dimensions in this data set. We can perform correlation, however the provided data set does not include specific values for LOS and risk of mortality. It only contains discrete values. To investigate, it would be necessary to have actual numeric values for these variables. So I think that's just because there's not a whole lot of data in there, but it could tell you more information like based on the data. Let's see what this gives us. What can be done to reduce the risk of mortality? So then it's giving us some thoughts on what we can do based on this data. We can explore potential actions or strategies. Although the data set doesn't provide specific details on individual patient cases, we can provide general recommendations. So as we get more and more data, we can go through and see what the relationships are and what the suggestion is to reduce the risk of mortality. So, I mean, that's what we can get if we can load up more data. So say we load up 40 records instead of 20 records. It may start delaying, or it may take some time to process that much data with the free version of ChatGPT, but we can still do it. So what I've done, though, is I've started using the paid version of ChatGPT Plus. And what that does is it introduces a range of plugins. And so there's one specific plugin. I'm going to go create a new chat. I'm going to switch over here to ChatGPT 4, and you see there's plugins here, and I've already installed the Code Interpreter plugin. So I'm going to click on Code Interpreter, and essentially what this does is it allows you to take a data set and then analyze the data set, not unlike what we were doing, but it also generates Python code so that you could take the Python code embedded in, say, Jupyter or some other Python application, whatever accepts Python, and then you can make that part of a larger application. So there's a lot more that this can do. So what I'm going to do now is feed in a full data set as an Excel spreadsheet. So let's see here. If I take a data set here, I'm just going to drag and drop and just say analyze. Let's see, drop in my spreadsheet here. It has upload file there. Analyze this data set. And whenever it says show work here, you can pick show work, and you can see that it's creating Python code and it's providing something back out. So it's reading the Excel file, it's showing me the headers, which is the information about the data. And so if I close this, now here's the information that it's giving me. It's similar to what we saw before with the free version of ChatGPT. This seems to be a unique identifier for each patient's medical record, for each encounter, the month the patient was discharged, and so forth. All the information is there: risk of mortality, severity of illness, race, age, gender, and so forth. Next, I'll generate some basic statistics. And so there's some statistics on the different values, and it shows the distribution, ROM SOI from 0 to 4, with the average of approximately 2 1/8 and 2 1/2, things like that. Average age is 50 years for this data set, so it's giving us some statistical information off the bat. And it looks like race has 3 missing values, so it may not be completely clean data, and then the primary diagnosis has 1 missing. So then it goes into some analysis of the data. And again, with any of these, you can go look and see what it's doing in the Python code and see what the result is. So it's actually creating the code for us, and we could copy that code, paste it out into Jupyter or whatever Python utility you're using, and analyze the data set ourselves. So, like for instance, data set's roughly split between female and 12,774 occurrences, and male 11,900. So it's basically split. There's the breakdown in race, primary diagnoses, so you can see the most common diagnoses. So just asking it for analyzing the data set, it gives us this wealth of information. So then we can go a little bit further. If we want to look at, say, breakdown by race, show me a breakdown of records by race. So then it's going to give me some information about those records. Again, it's generating the Python script, And there's a chart. It shows us the races broken down by the number of records with the count of race along the x-axis, and then it gives us an analysis of that data. And it's already giving us a column chart. So what we could do is we could take that Python script and we could embed that into whatever. But I could also tell it to take that Python script, because I know some providers use R. Give me the script in R. And so then it would adjust the script from Python into R, because I know that with SAP Analytics Cloud that I've dealt with quite a bit, it uses there's an R widget where you can embed R code in there. So rather than having to do the translation yourself, it does it for you. So all you have to do is just tell it where to find your file or feed in the data set, and then it does everything else for you. All right. So we've gotten insights, we've loaded up the data, we've gotten some automatic insights on the data. Let's just see what else it can do. Let's put in, give me some insights on this data set, and see what it provides us. So we can do some insights on patient demographics, health conditions, length of stay, and we see that the average length of stay is a little over 7 days, and they range from 1 to 277. And let's see here. Yeah, just let it finish typing here. There's a lot more that we could do here. Potential areas of further analysis could be investigating the relationship between variables such as age, race, and gender with health outcomes. So we could ask it questions about the correlation between or among those different dimensions, and see if we have a correlation of age, race, and gender that would maybe have a relationship on the outcome of the data. And that's based on the data set that we fed in. So evaluating the capacity and load of different nursing units. So we could look at the different nursing units, look at the distribution of the patient visits and encounter records to see if there's something we can do to alleviate their load, or do we need to add more nursing units, for instance. So there's a lot more that we could do here. Study the prevalence of health conditions across different demographics. So yeah, you can continue asking questions here. So let's see. Are there any relationships between age, race, and gender on health outcomes? Let's just explore that a bit and see what it gives us. So for race and gender, we use common comparison. Let's look at correlation of age and then proceed the group. So now it's creating a Python script to do that analysis. So let's see what it gives us here. Spearman's rank correlation coefficients between the age and the health outcomes as follows. So then it continues to give us insights. So as you're asking questions, so you're using your medical knowledge and a data set that's provided by your organization. Of course, this is anonymized data. You definitely don't want to feed in patient data into this system. You can do some analysis to figure out, okay, correlation coefficient is approximately that number, indicating a weak positive correlation, meaning that there's a correlation, but it's extremely weak. So same with age and severity of illness, weak to moderate positive correlation. There's a positive correlation between age and risk of mortality. Of course, the higher the age, the higher the risk. And then there are some outcomes here. We can go and read through all these, but I'll leave that up to you to explore. Also be mindful when interpreting these results. They should not be used to make broad generalizations about racial or gender groups. Healthcare decisions should always be based on individual patient characteristics and needs. So one thing I asked it yesterday was create an interesting dashboard with insights from this data set. And so it processed for a minute and it came back with something pretty cool. Oh, well, let's see. There's a lot of different outcomes here. I'll show you what I derived from this yesterday. But then there's the implementation. But what we can do is a demographics panel and then health outcomes panel. We might just do a health outcomes panel just to see what it would generate. And now it's creating the Python script to give us what we asked for. So it looks like it's creating a Python code to give us that dashboard of the automatically generated insights. All right, so let's see. Let me show you what I created yesterday. So from that data set, let's see. Yesterday, let me see if I can find it. Yeah, it looks like they're all gone. But let me see. So yeah, what it did was it created a dashboard for me. It looks like it's gotten rid of the visualization, but it actually created a 4-panel dashboard for me. I have to go back through and load the data and ask the questions and all that, and figure out why the data set that I use now is different from the data set that I used yesterday. But it actually gave me a 4-chart dashboard that gave me a breakdown of top 10 most common diagnoses, average length of stay for the top 10, severity of illness distribution, and risk of mortality distribution. And then we'd be able to take some of the insights, like if I ask it, create a chart showing the correlation between SOI and ROM. Let's see what this gives us. Oh, this is not cooperating today. It's not possible to create a correlation directly from the data given. Create a correlation, you would need a data set that includes numerical values for both. Okay, so I would need to go back and look at that data set to make sure it's clean. Well, let's look at this. Analyze this data set. Let's load up a different data set. So let's delete that. Drop it. Okay, so it's not letting me drop it in. So let's just do that. Analyze this data set and send it. So yeah, we need to make sure we're working with the right data sets here. So then this is going to analyze the data set, and it's going to give me a breakdown of all the same information that we saw before. It says it's similar to the original data set. And we'll see if this can give me possibly a chart. And yeah, it's going to keep breaking this down. I may just stop this because this gives a lot of really good information, but it's stuff that you've already seen. So let me stop generating here and just give it the same question and see if it can give me a correlation between SOI and ROM. So we'll let this process, let it create the script, and see what it gives us. So yep, this gives us a scatter plot. It looks like the other data set may not have had good information. So the scatter plot here is kind of interesting because the lines exactly intersect because of the type of data that we've got. It's not necessarily whole numbers, but it's numbers from 0 to 4. Actually, yeah, it's 1, 2, 3, and 4. So that's what it's showing us, and we have intersections of whole numbers here from 0 to 4. So that's why it's showing us that. But what if we decided we wanted to change the bubble size? Let's see if we can add or change the size of the markers to show the number of encounter records. Let's see what this gives us, because I want to see something where maybe there's a correlation between the number of encounters and the relationship between SOI and ROM. So let's see what this gives us. What I would expect this to give us is that same scatter plot. Yep, there we go. The same scatter plot there with the x's. The larger the x, the higher the number of encounters. So it looks like we have an encounter of with a severity of illness of 2 and a very low risk of mortality. But then we also have an increased number of severity of illness 4 with a high level of high risk of mortality. So maybe there's these are trauma cases or something like that. So then we can use our medical knowledge to be able to analyze this data with an eye on using the data. So, and that's what I've seen so far. So yeah, this has been using ChatGPT to analyze a data set just as the free version, and then showing what the new code interpreter can do in the paid version of ChatGPT. So there's a lot that we can do, especially around the analysis of the data sets. And especially like in Tableau, when in Tableau it has its own AI implementation that gives us the same sort of information, but it also lets you connect to that data set, how you normally connect to it in Tableau. Here you upload a data set to do your analysis, so it's sort of like a snapshot in time. But I hope this has been helpful with understanding. Let me know if you have any questions.